Welcome to Module 205C on feeder and branch circuit requirements for a single dwelling. Within this module, we're going to be looking at all the requirements that we need according to code in order to select our panel board, as well as to properly size all of our branch circuits from the breaker to our end device. This module has two different objectives that we're going to split into two videos. The first objective is determining the requirements for a single dwelling panel board. So we're going to look at how to select our panel boards and what kind of things go into that decision-making process. The second video is going to deal with our branch circuits. So everything from our branch circuit breaker through the wire to the end device is all going to be in that second video, and we're going to be doing a lot of calculations in that one. Let's look at how to select our panel board. There's a few things that we need to know automatically for making sure that we pick the proper panel board for our house. Number one, we need to know what our service size is going to be according to 8200. Number two, we're going to need to know what our wire size is and the ampacity of that wire. That's an important part, and we need to know the ampacity. The third thing we need to know is how many circuits are in the house. What are the actual loads? And lastly, we need to know what kind of breakers are we going to need in order to fill the panel up and service those loads. When we start to pick our panel board, the first thing we want to do is start with the ampacities. We need to know what the ampacities are that we found in 8200. And let's do an example. In our example, we have a panel that has a 98.6 amp calculated ampacity. According to table 2, we need to use a number 3 gauge copper conductor that's rated at 100 amps at 75 degrees. Now that 100 amp rating is important to us, and we'll come back to that in just a moment. The other thing we need to know is, according to table 13, we are required to have a 100 amp overcurrent device in order to protect this wire. So that's where we start. We know what our smallest possible overcurrent device is going to be. So we cannot choose any panels that are less than 100 amps. We can always choose something bigger, but we can't choose anything less. The other thing that we need to know is what are the bus bars within the panel board rated at. According to 8200, when we sized that out, that calculation was not only for our service conductors, but was also for the feeders after the service conductors. So by that rule, our feeders, which are our bus bars, need to have at least the same ampacity as our service conductors. So since my service conductor has 100 amp capacity, my feeders, my bus bars inside my panel also must be rated for at least 100 amps. Now if you think about that for a second, if we had chosen to upsize our wire to number 2 gauge conductor instead, the number 2 conductor at 75 degrees has a rating of 115 amps instead. So therefore, we would have to select a panel board that has a bus bar rated for at least 115 amps, even though we're still using only 100 amp breaker. The good news is, typically, when we go out and buy a 100 amp panel, the bus bars inside are automatically rated at 125 amps. But you should check with your supplier and your wholesaler to make sure that that is actually true for whatever you are buying. So now we've dealt with the first two issues. We dealt with what is our service size going to be according to 8200, and we dealt with our conductor ampacity. So now let's look at the other three things that we need to know. The first thing is we need to know how many loads are inside the house, as well as what kind of breakers are needed. When we talk about breakers, we have a number of different things that we can select. So some panels are built so that you can actually fit 2 breakers into one slot. These are called by a number of different names, including wafer breakers, half breakers, duplex breakers, and so on and so forth. The idea behind this is that by using these half-size breakers, we can actually double the capacity of breakers inside our panel. So if we buy a 24 circuit panel, by using the half-size breakers, we can actually increase that to 48 circuit panel. Keep in mind when we're doing our panel selection, there's other things that are going to come into play. If we have any 2-pole breakers, they're going to take up 2 slots automatically. If we're going to be using arc fault or GFCI breakers, they're going to take up 1 full slot. So we need to be aware of all those conditions. Let's look at this example here where we have selected the Siemens 100 amp panel, and on the actual rating it says 24/48. That means that this panel is rated to take those half-size breakers. So if I was going to use full-size breakers, I can fit a maximum of 24 breakers in this panel. If I'm going to use a half-size breaker, I can fit in a maximum of 48 circuits into this panel. If I use a combination of both, then I need to know kind of what I'm doing so I know how many breaker spaces are actually going to be utilized inside here. Make sure you are going over Rule 8108, because 8108 specifies that for any new development, we need to make sure that we're leaving at least 4 breaker spaces for future. That means if someone is going to build a brand new house today and they want to add something in for basement development, or they want to add a hot tub or something else later on, we need to make sure that there's enough space left in that panel for them to do that. Those extra breaker spaces don't necessarily have to be beside each other, but 8108 does specify that we need to accommodate at least one 2-pole breaker. So we want to make sure that at least 2 spots are side by side. So let's look at circuit loading. We want to make sure that we understand what circuit loading is and how many breakers each different load is going to be. A good clue is to always check the voltage requirements of the different breakers. If it says 240 volts, it's automatically going to be a 2-pole breaker, which means it's going to take 2 panel slots in order to accommodate that load. So the first thing we want to do is check the voltages of our loads. That tells us whether or not we have a single pole breaker or dual pole breaker. Typical loads inside a house that do have 2-pole breakers are your range, your dryer, your air conditioner, hot tubs if they have it. There may also be an electric water heater which may require a 2-pole breaker as well. So make sure you're double checking on all the different loads. After that, all you have to do is count how many circuits are required. Remember, 2 spots for any 2 poles, single slots for any single pole. You can't forget to add up all your common loads as well. We need to go through the electrical plan and add up all the outlets and lighting that are going to be considered to be general use areas. Section 26 tells us what kind of circuits need to be on their own dedicated breakers, such as microwaves and fridges and freezers, as well as how many devices that we can put on any single breaker. Remember, the 80% rule is going to exist here. So if we have a 15 amp breaker for our general use plugs or our lighting, we can only put on a maximum of 12 devices onto them. Just because we can put 12 devices on a single circuit doesn't mean we necessarily should. It is good electrical practice to not load them fully. It's a good idea to only put 10 devices on a circuit to allow us some flexibility just in case things change on the fly. At this point, you should know whether or not you're going to be using AFCI breakers or AFCI receptacles, because that's going to change the amount of space available in your panel. An AFCI breaker will take a full breaker spot, whereas if I use an AFCI receptacle, I can use a half breaker spot and then feed my circuit from there. So double check to make sure that you know which way it's going to go. Let's look at the other considerations and the things we need to think about. We already discussed making sure that we know what all the different house loads are and what type loads they are, such as single pole or dual pole. We also talked about 8108 and how it says that we must leave 4 breaker spaces open for future development. But we also have to put in some common sense, and having a conversation with our customer will go a long way to determine what their future wish list is. Even though code says that we have to have a minimum of 4 breaker spaces left open, the customer may want more breaker spaces depending on what their future plans are going to be for their house. For example, if they do not have a developed basement right away, we're going to leave more than 4 just to accommodate any other loads they want to put in there. There's other things that we need to know in order to select our panel. We need to know what our overcurrent device is, as well as what our wire ampacity is going to be. And then we need to know what kind of loads are going into the house. 8108 is important. Don't forget about that, and leaving 4 extra breaker spaces at least. Make sure you also have a conversation with your customer to know what their future wish list is in case they are going to require more than just 4 breaker spots. Review the information in this video and your module, and then when you're ready, continue on to part 2.